Welcome, viewers, to today's lesson on computer science. I'm Ahmed Ijaz Hussain, and today we'll be learning about resistive touchscreens. Lesson objectives. By the end of this lesson, you should be able to explain to me how resistive touchscreens work. In other words, if I ask you any questions about resistive touchscreens, say, what are resistive touchscreens? How is it that resistive touchscreens work? What are the components making up a resistive touchscreen? And what are the variations of resistive touchscreens? You should be able to answer all my questions with confidence and accuracy. Furthermore, you should be able to state the various applications of resistive touchscreens. And why is it that we use resistive touchscreens for these applications instead of the various other types of touchscreens? Before we go anywhere, we need to first understand exactly what are resistive touchscreens. Resistive touchscreens are touchscreens that make use of the pressure that is applied on a screen. This pressure may be applied by any device. It could be your finger, it could be a glove, it could even be a stylus. Anyhow, the pressure applied on the screen is then used by the system software to locate exactly where is it that pressure was applied by detecting at exactly which point did two layers, a resistive layer and a conductive layer, bend to touch each other. This design may seem very simple, but actually it's really effective. I mean, you got so many devices that use resistive touchscreens, such as smartphones, ATMs, and even all those devices that use styluses. Now that can make for a lot of devices that use resistive touchscreens. Now let's cover the main question of the day. How is it that resistive touchscreens work? What happens when you touch a resistive touchscreen? Well, whenever you touch a resistive touchscreen with enough pressure, a resistive layer will touch a conductive layer, as mentioned before. Even though these two layers are usually kept apart by teeny tiny dots that we like to call spacers. When these two layers meet, an electric current flowing between the two layers is changed at the exact point that you touched. This change in the electric current is recognized by the touchscreen software. When this happens, the software will then proceed to carry out whichever function is connected to that exact spot that you happen to have pressed. For example, say you've got an ATM and you've got these buttons on a touchscreen. Whenever you press one of those buttons on a touchscreen, the electric current flowing between the resistive layer and the conductive layer present within the touchscreen will change at the exact point you touched. This change will then be noticed by the ATM software, which will then carry out whichever link, for example, or a new page that may be linked to that particular button that you may have pressed. In the following diagram, you can see the various layers that make up a resistive touchscreen. First of all, you have the glass substrate, which acts as the foundation upon which all the other layers of the touchscreen are built upon. Then you have the plastic layer with resistive material, which touches the other layer, which it should be the conductive material layer or resistive material layer, depends on the touchscreen, of course, whenever you apply enough pressure. These two layers are then kept apart by the microdots, which are the spacers that we outlined earlier. On top of these microdots, you have the other layer, which is in this example the resistive material. However, it could also be the conductive material. Then, as the icing of the cake, you have the plastic layer. This is where all the bending occurs. It's like the top uppermost layer of the entire touchscreen. It's also known as the cover sheet for this reason. We'll be looking into the cover sheet later in this presentation. Now let's look at the various variations of resistive touchscreens. There are 5 main variations of resistive touchscreens. That is 4-wire, 5-wire, 6-wire, 7-wire, and 8-wire resistive touchscreens. Now in the following slides, we'll be looking into each and every variation of resistive touchscreens in detail. First of all, let's look at 4-wire resistive touchscreens. 4-wire resistive touchscreens make use of both the resistive layer and the conductive layer of the touchscreen to find the position of your fingers, or the x coordinates and the y coordinates of exactly where is it that you use a particular object or your fingers to apply pressure. This was the type that we had discussed much earlier. The amusing part of 4-wire resistive touchscreens is that at any and all times, only 3 of the 4 wires present, that would be one for the cover sheet, one for the back layer, one for the ground layer, and one for the probe, only 3 of these 4 wires are in use. That is the probing layer, the ground wire, and the probe wire. What am I referring to by the probing layer, may you ask? Well, what happens is that the cover sheet is probed by the back layer to find the x-axis, or the left-right axis, while the back layer, in turn, is probed by the cover sheet to find the y-coordinate, or the up and down axis. Advantages. 4-wire resistive touchscreens tend to be very easily made. Also, they're very inexpensive, and that's always good because, as I'll be mentioning even more, we live in a world that runs on money. They also have really low power consumption, so if you're using a 4-wire resistive touchscreen, you'll be sure to get a really long-lasting device touchscreen. But there are some small issues with resistive touchscreens. I mean, they're not really durable because you're always flexing the cover sheet on the top. Also, because of environmental conditions, the accuracy has a tendency to drift. However, this issue can be solved and will be solved by several other variations of resistive touchscreens. Now let us move on to 5-wire resistive touchscreens. Despite the similarities in the names of 5-wire resistive touchscreens and 4-wire resistive touchscreens, these two variations are actually very different. This is as 5-wire resistive touchscreens use an extra wire on the back layer. This back layer is actually made of glass. Also, in 5-wire resistive touchscreens, the cover screen acts merely as the probe for the back layer, where the positions of both the x and y coordinates are sensed. In other words, in 5-wire resistive touchscreens, the cover screen does all the probing with the scanning of the back layer, which is where the up and down axis and the left right axis of where you applied pressure are noticed. However, this requires a rather complex linearization design on the screen's edges, so it may be a little bit expensive sometimes. Also, in 5-wire resistive touchscreens, the up and down axis, or the y coordinate, is always found before the x, or left to right coordinate. Advantages. 5-wire resistive touchscreens will function even if there are any problems in the coating of the cover sheet. Also, when compared to 4-wire and 8-wire resistive touchscreens, 5 wires are much more accurate and durable. However, they tend to be rather expensive to manufacture, which can put off many consumers from buying this. I mean, even if fiber resistive touchscreens had so many benefits, would you buy them when compared to a much cheaper 4-wire resistive touchscreen? When all you want is a good touchscreen? You should really consider this question whenever you're trying to buy a resistive touchscreen. Alright, so in the following diagram, you can see the structure of a 5-wire resistive touchscreen. There's the glass substrate that acts as the foundation for all the other layers, as mentioned before. Then there's also the aforementioned insulating spacer ducts, or the marker ducts. There's also a conductive coating, both beneath and above the marker ducts. Finally, as the very top layer, there's a flexible, hard-coated outer membrane. This membrane is where all the bending of the cover sheet occurs. However, it's much more accurate and durable in 5-wire resistive touchscreens, as we may have outlined earlier. 6-wire resistive touchscreens. 6-wire resistive touchscreens are different from the various other variations of resistive touchscreens in that they use an extra ground layer behind the back layer, or the glass layer. They also make use of silver carbon processing technology, which you can say in a very short statement is very advanced. 6-wire resistive touchscreens are very useful in that they allow for more than 35 million touches. Now that is very useful because you're always looking forward for a touchscreen that has a really long touch life and that you don't have to replace all the time. Also, these touchscreens can eliminate noise. Mental note, this is, I'm talking about here, the electrical noise, not the sound noise you hear from traffic, so forth. They also have a very narrow border for simple integration and accuracy, because nobody likes an extremely thick border. Finally, they are supported by USB controllers with chip-on-cable solutions. This can be useful in several applications. However, like 5-wire resistive touchscreens, 6 wires tend to be expensive to manufacture, which can really put off potential buyers. Now let's look at 7-wire resistive touchscreens. Basically, they just add another extra two sensory lines to decrease any drift or degradation in the accuracy due to environmental conditions. This is a problem that is faced in both 4-wire and 8-wire resistive touchscreens. In these touchscreens, you've got a much more reduced accuracy drift due to the extra sensors, and that's all. And a reduced accuracy drift is always useful. However, there's also an additional manufacturing cost, which, as mentioned before, is never liked by any customer. And last but not least, we've got 8-wire resistive touchscreens, which is basically another variant of 4-wire resistive touchscreens. But unlike normal 4 wires, 8 wires make use of an extra 4 sensors to stabilize the entire system and to decrease any accuracy drifts from changes in the environment. 8 wires tend to be found in much larger touchscreens, as these are the ones that tend to be susceptible to drift. An advantage of 8 wires is that they have a rather stable touchscreen, so you don't have to worry about any problems in the touchscreen. Also, like 7 wires, there won't be that much of a drift in accuracy. However, in 8 wires, constant flexing of the cover sheet can lower the accuracy and degrade the linearity of the coordinates. Also, there are increased manufacturing costs involved in 8-wire resistive touch. Advantages and disadvantages of resistive touchscreens. When compared to several other touchscreen technologies, such as capacitive touchscreens and infrared touchscreens, resistive touchscreens have many advantages and disadvantages, some of which we will look at below. To begin with, resistive touchscreens tend to be rather cheap. Also, they tend to be compatible with non-moving objects, such as a stylus or fingernails. So yeah, whenever you use a stylus to draw on something, you can thank resistive touchscreens. Also, you can use them with gloves as well as your fingers. Always useful whenever you're on the move, or if you just happen to be wearing gloves and you're like, whoops, I have to use my phone. But there are some disadvantages which we should never ignore. Cause you'll have to calibrate your resistive touchscreen a lot. Also, you'll have to be really careful cause resistive touchscreens are not very durable. And the cover sheet is very fragile and easily damaged. Also, resistive touchscreens suffer from an inability to support multi-touch gestures, which can be a very annoying problem whenever you're trying to multitask. Then there is the lack of visibility in direct sunlight. So you have to be a little bit careful where you're traveling with a resistive touchscreen. The picture you see here is just one very common example of what happens when your cover sheet cracks. This is why you have to be very careful with resistive touch. Applications of resistive touchscreens. When you study resistive touchscreens, you should be able to understand the various uses of resistive touchscreens. They have a huge range of purposes around the planet. However, when we look at these uses, you should also be able to understand why is it that we use resistive touchscreen for these reasons. So let's look at them. First of all, you've got point of sale applications such as the industries, hospitality, and general retailing. Because in all these applications, you need a touchscreen that can resist environmental conditions and something that has a rather long touch life. Two factors that are present in all resistive touchscreens, especially 5-wire resistive touchscreens. Then you've got small to medium sized applications such as consumer products, medical industry, mobile devices, such as one you may be using to read this very presentation right now, and office automation, like all those computers your boss may have in his office. We can use resistive touchscreens in this situation as well, because they're reliable, inexpensive, have rather low power usage, always useful for the power bills, excellent resistive optics. They also accept a variety of input devices like gloves and styluses. All these applications I just listed require all these factors whenever you're considering a touchscreen. Then last but not least, you've got the fact that you can use resistive touchscreens in cold climates and constructive sites. You can use resistive touchscreens here as well because you need in these areas you need something that's reliable, inexpensive, and can support input from gloves, which can be a really big issue you can run into in other touchscreens, like capacitive touchscreens for instance. They may seem rather modern, but when you go to a cold area and you're like, I need to wear my gloves and use my touchscreen, you won't be able to do that. So, and sometimes it's better to stick to the old-fashioned resistive touchscreen. The pictures here just look at some applications of resistive touchscreens. Like here, you've got a consumer product, a dual screen, which many of you may not have actually seen, but that's actually a very possible thing you can do to your monitor. You can have two screens on each side. In this case, you've got resistive touchscreens being used, as they can be rather useful in several aspects that we have covered earlier. Now, you've also got a picture of a person wearing gloves using his touchscreen. But do you think he would be able to do that if he had a touchscreen that was not a touchscreen? No, you wouldn't. So that's another application of resistive touchscreens. The ability to accept input from gloves. In the last picture, you can see someone using a stylus on his device. The only touchscreen that can actually accept such an object being used on the screen would be a resistive touchscreen. So yeah, that's another use of resistive touchscreens. The ability to support non-animate objects that we have outlined earlier. In summary, resistive touchscreens are touchscreens that make use of the pressure that you apply on a screen to locate the exact position of where input was provided. They have two layers, a resistive layer and a conductive layer, which are kept apart by spacers. However, these two layers will bend to meet each other whenever enough pressure is applied on a spot. There are 5 main types of resistive touchscreens: 4-wire, 5-wire, 6-wire, 7-wire, and 8-wire touchscreens. Resistive touchscreens have several advantages, such as their cheap cost, low power consumption, and don't forget their compatibility with inanimate objects, and disadvantages, such as their lack of durability, their inability to support multi-touch gestures, and the really bad visibility in direct sunlight. Last but not least, resistive touchscreens have a huge variety of uses, ranging from the medical industry in itself to general retailing. Here are some questions to test your knowledge on resistive touchscreens. If you listened to this presentation and watched it very carefully, you should be able to answer the following questions. What are resistive touchscreens? Explain how resistive touchscreens work. Explain the variations of resistive touchscreens with examples. List 3 applications of resistive touchscreens, along with why we use resistive touchscreens for these purposes. And finally, what are the advantages and disadvantages of resistive touchscreens? If you can answer these questions correctly, I congratulate you, because that means you have now fully understood this lesson. Congratulations! Welcome viewers to today's interactive video. I'm Ahmad Ijaz Hussain, the creator of the presentation you are watching just a few minutes back. And in this video, we'll be looking at even more information on resistive touchscreens. First of all, let's do a little bit of a recap on everything we have learned from the presentation I made. Hopefully, you are all listening. First of all, what are resistive touchscreens? No answer? Fine. Okay, I'll tell you. Resistive touchscreens are touchscreens that make use of the mechanical pressure that you apply on the screen, like this, to notice exactly where is it that you put in input. And how do they work, may you ask? Unless you were listening to my presentation, in which case I say congratulations. Basically, whenever you press the touchscreen with enough force, what happens is that two layers, a resistive layer and a conductive layer, bend to touch each other. However, these two layers are usually kept apart by teeny tiny dots we like to call spacers. It probably look like this, but probably not that big. Remember, they're small, very, very small. Either way, when these two layers touch, this changes an electrical current flowing between these two layers. This change is then noticed by the touchscreen software, which then proceeds to carry whichever function is carried or connected to just in that particular spot. A good example of a resistive touchscreen would be this charming 3D system right here. Sorry if it takes a while to turn on. Oopsies, I need to reset the brightness. Yeah, you guys can see something. So my point is, if you look carefully, hold the stylus here and you can make the entire screen move. I can even tap stuff like this. And yeah, this shows that resistive touchscreens are actually compatible with inanimate objects, like this charming stylus I have right here. That's one of the many advantages of resistive touchscreens. Furthermore, resistive touchscreens are also compatible with gloves, which is always useful, like say you're going gardening. I'm like, whoop-de-doo, gardening. Oh my god, someone has called me. I need to answer the phone call. In that case, you take out your handy resistive touchscreen and you can save the day. Also, they tend to be really cheap. And that is very important in a world where money runs everything. Also, they have a really low power consumption rate, which means they can survive for a rather long time whenever you're using them. Which is good, because you want a phone that can survive for a really, really long time. But they do have some disadvantages. I mean, they tend to not be very durable or accurate due to environmental conditions. Also, the cover sheet tends to become very easily damaged. That ain't good. Because you don't want a non-working touchscreen because the cover sheet stopped working. That's bad. That's very, very bad. So that's why if you want a really well-functioning cover screen, please do not take resistive touchscreens. Also, they have really bad visibility in direct sunlight. So if you're going to be walking around in the sun all the time with that resistive touchscreen of yours, change your mind. Take some other touchscreen. Just saying. So yeah, I hope you've learned something from today's lesson, along with my charming friend, my 3DS. And goodbye, viewers. See you in the next video. Bye. Thank you, viewers, for staying with me throughout this journey through the mighty realm of resistive touchscreens. However, in case you want even more information on resistive touchscreens, which I would gladly recommend, here are some nice links you can use to find even more information on resistive touchscreens. Once again, thanks for listening and watching this presentation, and goodbye.